All right. So can everybody hear me? Okay, cool. So hi, everybody. Once again, I'm here to talk a little bit about how to manipulate relational databases in KNIME. Common databases, you're probably going to be working with SQLite or MySQL, so this fits the bill. And I think the way this short class is going to work is that I am going to show a few slides explaining how the manipulation of databases works in KNIME. And then I'm going to, just like last time, show a small demo of how a workflow that does that. So for those who didn't see me last time, I am Aline Bessa. I am a data scientist at KNIME, working in the evangelism team, providing support for professors, doing things like this guest lecture. Without further ado, then let's talk about relational databases. So one of the examples in which you want to use a relational database is for classic ETL. I don't know if you folks are familiar with this abbreviation, but it stands for extract, transform, and load. And I don't know if Professor Hamed has already explained the challenge that you guys are going to be tackling this semester, but it has a lot to do with ETL. It has a lot to do with maintaining, updating different tables in a database, okay, that are based on New York City data. So in this example here, we have in the extraction part, access Europe customers' data from the cloud or from a database. So, you can also read data from a database or access US customers from a web service by performing, I don't know, a GET request. And then there is all the transformation, right? I don't know if you folks remember from our last class, but transformation is usually done with those yellow nodes, row filtering, data cleaning, data blending, anonymization. So all of this is data processing transformation. And then in the end, you often want to get this information and update tables on a database that you're going to be keeping, right? So in this particular example, it would be customer data. And a relational database is based on the relational model of data. So it sees data as a tensor, really, in particular a 2D vector, if you prefer to use this denomination. You're going to have data that is going to be organized in 2D tables, right? So it's a 2D tensor, and usually the columns correspond to the attributes and the rows correspond to instances of these attributes. So even in the examples that we discussed when I was introducing KNIME to you, all of those things were relational tables, right? So they were basically in the perfect format for you to upload them onto a relational database. It's a very standard way of working with data that has some structure, different from images, different from text that is more unstructured. And once you store this information in a database, you can query this information and you can delete this information and upload this information and overwrite this information using SQL. I don't know if people say SQL or SQL. I say SQL. But basically is this language that is not a programming language. It is a querying language that allows you to obtain a subset of the records, combine tables, delete parts of tables depending on values of the attributes. You can also use SQL to delete entire tables, create tables, and so on and so forth. I don't know how far you are in the course, right? In the understanding of databases. That's why I'm giving all the information, right? And maybe you know all of this and you're already bored, but yeah.
We've done the modeling. So we're gonna move on to one session of relational algebra, and then we're gonna start SQL.
Cool. All right. But you shouldn't be scared of anything I'm saying, and obviously if you have any questions, just ask. So KNIME has a database extension that comes as a built-in. So once you install KNIME, most of the database things are going to be there. Some big data things, if you want to Access, Azure, or, Amazon S3. Maybe, I'm not sure, but maybe you have to install something extra. But for all of the classic databases that we call, the JDBC compliant databases, what does it really need, JDBC, this abbreviation? It means Java Database Connectivity Driver. It's a small piece of software that allows these different JDBC data, that allows KNIME to connect to different databases. So yeah, MySQL, Postgres, all of them are JDBC compliant. Oracle, for example, has a driver that is proprietary, so it's a bit more complicated to connect to that via KNIME, but it is also possible, right? You just need to get a few extra instructions. I'm not going to go down there. But if you have any questions, if you want to use Oracle for some reason, there's a lot on that in the forum. And then you can also visually assemble complex SQL statements without having to write SQL. So I'm happy that Professor Hamed is going to teach you the SQL language. It is very important to know that. But you don't necessarily need to write the statements in SQL within KNIME. The nodes write the statements for you, right, as you go. And then in the end of the day, this extension allows you to harness the power of your database within KNIME. So again, you don't have to do all the database processing outside, write something on a file, and then use KNIME to process this file, right? You can do everything inside KNIME. So this example here, for example, we connect to a SQL database. We have here a SQLite connector, right? That's the first node. And I don't know if you remember that last time when we met, the outputs, the ports were mostly black triangles, and I told you that they were data that is inside KNIME. But the ports here are different. These magenta ports are connections. So the port of this is just one connection. And then this node here, the database DB table selector, gets this connection, so it knows where it should be selecting tables from, and selects a table for you, right? In this case here, it selects all of the rows from a table named SS13PME. And the output of this is now going to be not data inside KNIME, but a table in the database. So everything is happening in the database. No data has been materialized within KNIME. We don't have those black triangle arrows, those black triangle ports here. And this is good for efficiency. So even this thing here, select everything from this table here, is already a SQL statement. But I'm not exactly executing it now in a way that materializes as data. And then why? Because maybe I want to do further processing in the database before bringing this data to KNIME. So if I were getting the data now, it would be bad, right? Because I would have to do more connections to the database. So we do all the processing in the database, and then we get the data we want to KNIME. So for example, we selected a table. It's still in the database. You see this maroon square here. Then we want to filter a column. Then we want to remove certain rows from that table. For example, there is an attribute named COW. So you just want to keep rows in which COW is not null. So you don't want missing data. Maybe you want to remove the attribute. Maybe you want to perform a group by operation. This is something that you're also going to learn. But basically, in a table, you have the attributes. So you can group the values of one attribute based on the values of another attribute, and then represent this as the average, as the most common value. It depends on how you group the data. But what does happen when you perform a group by is that you end up with a different table that is going to have a different format, right? So it's not that original table. It's usually a more compact, a tinier table that corresponds to grouped information. And then maybe you want to also join to different tables, right? We have one table here at the top that is the original one, without some columns, without some rows, but still with more or less the same structure. And maybe you want to join that with this little table that you created here using the group by node. So you can use the DB joiner node for that. So we do have equivalent nodes for all this processing. for data that is inside KNIME. But as I said, all of this is happening inside the database, right? You connect and all these operations are inside the database, and this makes for a much more efficient process. And then when you're happy, right, when you have the data in the format you want, so this the DB joiner here said that this is the last in database processing that we want to do. You can export this data. So maybe you can write this back, it's a new table, right? It's a table that is joining two new things that you processed. So you can either write this table back to your database. You have this node here, DB connection table writer, and it's going to save this table to the database. It is going to be the same database that you connected here, right? If you want to write to a different database, you are going to need to first connect to this new database and then write. So you're going to have to use another instance of a connector node. But here we just want to put it back in the same database. Not only do we want to do that, but we also want to finally bring this data to KNIME. So if you want to visualize this data, if you want to perform a loop over this data, if you want to, I don't know, leave this data available through a REST API interface, then you need this data to be inside KNIME, right? You have to stop interacting, doing this in database processing, and you actually need the data in KNIME. You cannot go straight from here, from the joiner, and put a visualization node and try to see the data. No, you have to bring the data to KNIME. So then you have this node here, DB reader, that is going to get this table you generated in the database, and it is going to import it into KNIME. And then you can do visualization, you can create a machine learning model, whatever you want. But only now that you have the black triangle, only now this data is actually inside KNIME, okay? Now let's talk a bit more about database connection. So we have dedicated nodes to connect to specific databases. It's the JDBC drivers are included. Here are a few examples of the connectors we have. So Google BigQuery, Snowflake, Oracle, MySQL, you know, and if you want it to be more generic, you can use the DB connector node, and then you have to supply this node with a little bit of information on the JDBC driver. There are some other connectors that I mentioned to you, like Hive, Impala, Vertical, but they are for the structures that are also important for data warehousing, but we don't really call them databases, right? We call them, you know, lakes or just, you know, cloud services for storage. It depends. And how about this in-database processing? What do we have available? We have a lot. So many of the things that you can do with the data directly in KNIME, you can also do play in the database, right? And the thing that nobody tells you is that all of this processing that you do with these nodes corresponds to SQL statements, but it's implicit, you see? You're not really writing the statements. Just by using these nodes and concatenating them, you're writing implicitly super complicated SQL statements, right? So for example, DB column filter, right? You wanna get just a few columns. So this is a select statement, right? You will see more about SQL in the future. And I think it's cool that you are learning about this before learning SQL, because at least I personally think that it's more intuitive to understand the processing like that visually than by writing the statements, right? I think it's easier to understand. So yeah, you can filter rows, you can filter columns, join and concatenate tables, extract samples. You can sort the data in the database. Of course, that is an expensive operation, but yes, you can. You can bin numeric columns. You can aggregate the data doing group by operations. Or if you want to do something more customized, you can also write your own query. If you really want to write the SQL queries, the SQL statements, you can also do that. As you know, KNIME is low code, right? You can do most things without any code at all, but if you do want to code, and also by that I'm including, if you do want to write SQL queries, you're welcome to. And the configuration of these nodes is super similar to the classic KNIME manipulation nodes that we have talked about before. And they allow you, as I said, the whole pipeline of these nodes, they correspond to complex SQL queries. For you to not forget this, these are the different parts that you're going to be seeing a lot when you're playing with databases. The magenta one that creates the connection, right? That's where you inform where the database is and connect. And then you have the DB data part, which is this maroon one, that will carry with it the output of the SQL statement that it represents implicitly, and also keeps the connection information going. And this is important, right? Because if you want to write this to that database again, it's important that the connection information is still there. So the node knows where to write that to. So yeah, the DB table selector, right? So this performs a SQL query that selects a table. And then in this maroon part, you have the SQL statement, but you don't have the materialized data. It's only when you bring it to KNIME, but you have everything there. The skeleton is there, right? To actually materialize into data. Now, how do we read and write or load data into a database with KNIME, a relational database? Well, to read, as I said, first you start with the connector and then the DB table selector. You usually want to read a table. You can read many tables, but you usually start reading a table. You usually start selecting a table, right? Not even reading, but selecting a table. And for that, as I said, you use the DB table selector node. It is going to take the connection information and construct a query. Here's the configuration of this node, the DB table selector. You're going to have to give the name of the table. Sometimes you have to give the schema. I'm not going to go into further detail here because you folks haven't seen this yet. But maybe you already know that a database is this big house with lots of tables, right? And these tables can relate with one another. So usually you want just a few tables or something like that. Here to the left, you have a few of the nodes that we have that allow you to do reading and writing. DB delete, deletes tables, DB insert, inserts tables, loading tables, merging tables, reading the whole content of a table, updating a table. So these are nodes that allow you to perform these more general queries, right? So just reading, loading, writing, not really processing, just actually acquiring the data or uploading the data back somewhere or deleting the data. And after you select the table, you read it, right? You want to read the whole content of it within KNIME. If you want the data to already be materialized inside KNIME, right? So as I told you before, after you select the table, you can do a lot of in-database processing. And maybe just in the end, you want to read actually the result of the SQL query that corresponds to all of that in-database processing. And here, the SQL that corresponds to this in-database processing is going to be very simple, right? It's just a selection of one table. And then you want to read it inside KNIME. So here in the maroon part, you have the SQL query that corresponds to all this processing that occurred inside the database. In this case, it's very simple. It's just a selection. And then with the DB reader node, you get this SQL statement that is here. It can be very tiny. It can be very complex. It depends on what you do. And the SQL query is executed and the data is materialized into KNIME. So black triangle, KNIME data table. And now you're happy to further process it with the yellow nodes if you want to. You're happy to create, you'd be happy to create machine learning models, visualize the data, whatever you want to do. So is it clear? Let me just to make sure that you understand one thing. You see that this is a maroon port, right? So all of this processing here, table selector, filtering, blah, 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 group by, joiner, all of this generated a very complex SQL query that is optimized and all of that. And this is what you have in the maroon port. When the DB reader node connects with the output of this node, right, gets this SQL statement as input, it executes it, and brings that data that corresponds to the output of that statement into KNIME. Okay, so let me know if anything is not clear. It may get clear as well when we go over the demo. This is an interesting node. I'll try not to talk so much about these specific nodes because you're still going to learn the algebra and all of that, but an operation that is very, very common in databases is group by. For example, say that this example is not going to be very nice, I don't think. It's a bit sad, sorry, but it's what came to my mind, and it's at least relevant. But when we had the peak of the pandemic, right, when we had COVID, people were basically in the hospitals, they were taking the numbers of people who were testing positive, right? But this information is completely disaggregated. What we really wanted to know when we were reading the news was how many cases you have per state. So you have to aggregate this information per state. So if you see case as one attribute and state as another attribute with a group by, you can basically aggregate all of the cases per state, right? You sum all of them per state, and then you end up with a new table that has just the 50 states in the United States and the total numbers of positive tests per state. Just an example that might be easy to understand, even if it's a little sad. But yeah, you will learn many applications for group by, but yeah, humans don't deal very well with information that is disaggregated, and you usually don't want disaggregated information for visualizations, right? So sometimes it's good to have disaggregated information to create a model, because then you have lots of instances and you can create a model, for example, to predict what state is going to correspond to the next positive case, and then, to build that, it's nice to have all of the instances in all of the states, or disaggregated data if you want to do some kind of forecast. But for visualization and for a bunch of different data analytics activities, you want the data to be aggregated somehow. So you can do this in the database with the GB group by node. And the configuration is such that you specify what column you want to use to aggregate the numbers. And then there is another tab that allows you to decide what other column you want to aggregate. So in our example, it would be cases, right? And how you want to aggregate it. Do you want the total? So do you want to just count? Do you want the average? What do you want? So do you want the most common value, right? Say that it's not a number, say that it's a string. Do you want the most common value? So it's pretty intuitive how to configure it, and then it gives you this new smaller, in this case, it gives you the SQL statement that materializes into a smaller, more compact, a grouped table. I'm not going to talk about this one. Concatenate. So this is another node that combines the rows from 2 or more tables with shared columns. So say that people are collecting data on who still has a landline at home, right? So if people are doing this, different people working for the census, and they're doing this in different states, they can try to combine all of the data in the end, because they're going to have the same attributes, right? They're using the same forms, but the information is coming from different states. So you can aggregate all of that by performing a concatenation. And again, here you don't have the data yet, right? You have the SQL queries that will materialize as data. Okay, you're creating the schema here, you're creating the structure to get the data. You see, I changed my example. I use landlines. It's happier. But yes, just so you remember, yeah, these maroon parts here, they get to SQL queries, right? This is a SQL query that does a selection. This is a SQL query that does a selection. The node GB concatenate will have access to what attributes are present in each connection, and then it will generate a new query that corresponds to their concatenation. And you can just
is this concatenation, is it actually doing a join, or it
no,
just puts
it's
a
only
table next to another?
one table. No, it's not a join. It's If they have the same attributes, we just concatenate the data. We end up with a table that has
okay.
the
So
same columns or the union of the columns, if some columns are present in just one of the tables. You pick or the intersection of columns, but it's basically the same structure with more rows. It's not a joiner. We do
okay, so
have
it's actually doing a union instead of
yes,
okay.
yes, it's doing a union. It's because there is not a very good verb for union, right? Unioner sounds really bad. So we have joiner, the verb, and we have concatenate, but it performs a union. And then now we have the joiner. Oh, just one detail. So did you just to make it very clear, it does allow you to concatenate tables that they should have columns, attributes in common, right? So otherwise, why would you be concatenating them? But maybe for a certain state, you collect information on something else as well. So you have a few more columns. So you can decide if you want to keep all of the columns, even if for some states you're going to have missing data, or if you just want to keep the intersection of the columns. So you just want to, so in this concatenated table, you just want to keep the columns that are present in every single table that you're using. Okay, so it can take the union or the intersection of the columns. And if there are duplicate rows, if there's duplicate data, it's handled very easily as well. The ID of the instance gets a suffix, and then nothing gets overwritten. You don't lose data because it gets overwritten because it's a duplicate, nothing like that. Because I don't know if you learned this already, but in a database, every single row in a relational database should have an identifier that is unique, right? We call that a key. So that's why it's important to make sure that you have no duplicates in these keys. So, nothing gets overwritten and you keep all the data. And then you have the joiner. It combines the columns from two different tables. You have to have, again, one column that is common to both tables. And ideally, this column works as a key, so things are unique. This doesn't always need to be the case, but it should be the case. And then you can decide what columns you want to keep when you join these two tables. How do you want to join them? So, for example, you can have a table, you have a common key, SSN, right? SSN is a unique number. So say that there is the SSN, one table has the SSN, and whether or not you have a landline in your apartment or house. And the other one has your SSN and the football team you root for. So if you want to join these two tables, you are going to join on the SSN, right? Because it's this information that is present in both tables, and that allows the records that are in one table, the rows that are in one table, to align with the others, right? If I root for the Packers and I do not have a landline, that is my information, right? I don't want this information. I don't want my information in the final joint table to say that I root for another team or that I have a landline. So things need to be properly aligned when the tables are combined, right? And the key does that, right? Its identifier does that. And it's very common when you're studying databases to talk about the left data table and the right data table. And you do a left outer join or an inner join, or, you're going to see that when you learn the algebra a little bit. But since you don't know that, I'll just say one thing. The table that goes at the top, right? Because in KNIME, the workflows are always from left to right. So what corresponds to the top here, and it comes here to the DB joiner, to the stop port, this is going to be the left data table, and the bottom port is going to correspond to the right data table. This is what I want you to know right now, that the top is left and bottom is right. Because when you learn more about manipulation of databases, you will see that, when you're performing joins, this whole idea of left and right plays an important role. Then we already talked about it, the DB row filters. So, this is the configuration. You basically specify what columns you want to use for this filtering. In this case here, it's a column named estimated yearly income. And then there are many things that you can do to specify the criterion that you want to use for filtering, right? So in this case, you just want to keep those records, those rows for which the values for this column here, this attribute here, are not null. And by doing that, you are filtering the missing values, right? So in this particular example here, we connect, right, to a SQLite connector. Here's the connection. And then our in-database processing is going to correspond to these two nodes. I select a table, very common. This is usually going to be the first step. And then I do this filtering here. And after this is done, I'm happy with the table. I'm happy with the SQL query. And then I pass this to this DB reader node. It is executed. And then I have a data table inside KNIME. Now, how about writing? Writing allows you to create tables directly in the databases, or also if you don't want to create a new table, you just want to insert or update values in a table that already exists. This is also possible. Deleting rows from a table, this is also a writing operation. It can be seen as a type of update. And what you usually need is, again, the connection, right? Here we are, again, connecting to SQL. We selected a table, and now we are creating DB connection table writer. You can create a table as a selection, or for example, if you have an external table in KNIME, say that you have a data table, a CSV. You want to send this CSV, you want to insert this CSV that has a tabular shape into a database, right? And turn that into a database table. So you can also send this using the DB writer node, but then you also have to pass the connection, right? So you want to write this table, but where? And then you pass the connection. If you want to insert data rows into an existing table, same thing. Maybe all of the data here has the same columns that correspond to a table that you already had in your database, and you actually just want to get the rows that are here and insert in this table that already exists. So depending on how you configure this node, you can do that. So it's DB insert, right? DB writer is just going to create, just going to insert rows into a new or an existing table. But the insert is not going to create a new table. It just insert the data rows into an existing table.
So, Aline, a question. With the DB writer, there is no need to create the database first before.
No.
Okay.
No need.
That's interesting.
You can just get, say, a CSV and just send it. And then you configure to specify types and details like that. But
Awesome.
KNIME does a good job at predicting the types based on the values as well. Again, if you have external data, you can update a table with this external data. Just if it's a table with the same columns, you just update the matching rows. You can insert new rows with the DB merge as well. And you can also delete matching rows using the database delete node, right? You can send this table reader, and everything that matches the information that is here gets deleted. So that's also a way of specifying very explicitly what you want to delete from a database table by giving a table with all that you want to delete. It matches and does that. But you can also just select a table doing the DB table selector and then apply the deletion. There is a node for that as well. So this is something that you're going to be doing a lot because the thing with databases is that they usually get updated, right? Why would you use a database system, right? Why not just use files? Or why not just use memory? Why would you keep this information? Because you want to have access to it again, right? If it's something that you never want to see again, or if it's something simple, then it's a file, or if it's something that is not connected to other sources of data, you just keep a bunch of CSV files and that's it. But a database, it's this living thing, right? In which the different tables have relationships with each other, and you want to keep accessing that information, updating that information. That's why in the project, you're going to be playing with like an interface, right? So people can send more data and all of that. And that's why it's so important to know how to insert data into an existing database, because you're not going to be creating a new database table every time you get new information from a customer, right? You have to find the table and then you have to insert the data that the customer just provided to you in that table. So in this particular example here, we have a table reader node. Maybe this table reader node has information for a bunch of new clients, and you want to send it to a table that you already have in your database. So this manipulation here, I don't know. This is not necessary. It's just something in this slide. Maybe not even very didactic. The whole point is you have a table, right? Black triangle, and you wanna make sure that all of the rows in that table end up as part of a table that you have in your database. So you use the DB insert node, and obviously you pass a connection. And it is very important that the column names match exactly. So if you want to include everything that is in this table, all of the rows that are in this table, in a table inside your database, the column names need to match exactly. Otherwise, you won't know where to insert it, okay? And this is just an efficiency configuration as well for the DB insert node. You can increase the batch size or reduce the batch size for performance, because you don't want to write, say that the result of this table manipulator node, which is the data that you want to insert, has 1 million rows, right? You don't want to write one by one on your database. This is a lot of communication between KNIME and the database, right? So this is a lot of bandwidth. You don't want that. So you want to write 1,000 by 1,000. You want to write 10,000 by 10,000, right? So it's just one single transaction, one single operation, sending a big batch of rows to the database at once. This is more efficient. There is also the DB writer node. In a second, let me have a sip of water. So again, if the table already exists and you want to use the DB writer node, it's going to do something very similar to what the insert node does, right? It's going to insert the data rows into that table. Again, the column names need to match exactly, right? If the keys in the information that you want to write in the database are exactly the same for the table. Sorry, let me try to rephrase it. This file reader, if it has keys for each one of the rows and the keys coincide with what you have for the table, you might end up overriding the rows you have in your database, because keys need to be unique. If they're not unique, sometimes they just override the content, which can be what you want, right? Maybe it is really, maybe now, Aline, I have the same SSN, but I don't have a landline anymore. So the moment this information is passed to the database that previously had me as a record, right, with my SSN and saying that I had a landline, now this information is going to get overwritten because it's the same key, it's the same SSN, but now stating that I don't have a landline anymore. So you have to be careful with that when you're performing these writing operations, because they can be a bit aggressive, right? Make sure that, you know, if you don't really want to modify the information for me, if it's a different person and there's a typo in the SSN or something, make sure that everything is corrected so that you don't overwrite information that you previously had. Is that clear? If it isn't, you can ask. And if the table does not exist, right, it creates this table according to the specification. It is going to ask for a little bit of specification. It figures out the types for the different columns, but it's nice to go and look. And as I said, there are a few configurations as well that you can check in order to make this process of writing more or less safe. So for example, if you want to make sure that you're not going to be overwriting information, you can specify this here as well. And if you want to, every time that you send this table, you want to remove the previous table and overwrite the table completely, you can also enable that, right? Enable to overwrite the existing table. So if the table exists, but you wish it didn't, you can also override it completely. Very aggressive operation. You almost never want to do that. Only when you're testing the system, right? Because then you're always deleting. When you start playing with databases, you're going to see you're always going to be deleting tables and recreating to check bugs, to see how it's working, to change the schema, what attributes you have. But once the thing is in production, you're not going to be deleting the tables, okay? So it's nice to be careful with that. And then we have the GB loader node that inserts data rows into an existing database table. But I'm not going to talk so much about this one. Let me see. Yeah, I think I won't talk so much about those because I want to show the demo as well. So yeah, this one DB connection table writer creates a new database table based on the input SQL query, right? So here you're gonna have say that you select a table and you perform a grouping operation, and now you want to create a table inside your database that corresponds to that grouping operation. So you can do that DB connection table writer. It gets the SQL and it creates a table with that schema. The deletion, pretty straightforward as well. Records that match whatever you're sending here in this KNIME data table. Everything that match is going to be deleted. Once again, the column names need to match exactly. Or if they don't match exactly, you need to identify in the configuration what columns you want to take into consideration to perform the deletion. Now I want to talk a little bit, before showing the demo, I want to talk a little bit about efficiency. Just, good practices that I want to be aware of. When you're using in KNIME, the database extension, make sure that you're using the new database framework instead of the legacy versions. So because KNIME is retrocompatible, you are going to have a lot of nodes that have this word legacy in parentheses. Don't use them. They're not as efficient as the new version. So, you can, if you see a workflow that has this on KNIME Hub and it seems interesting, it seems like something that may adapt well to your project, feel free to download that workflow, play with it. But when you actually want to use that for your project, change these legacy nodes to the newer nodes, okay? Avoid using the GB connector node multiple times. Connecting to a database is a little expensive. And unless you need to open up lots of channels, lots of parallel connections to the database, maybe to speed up a writing operation, don't do that because it's a costly operation. Again, push processing to the database as much as possible. So we have so many of these nodes, right? That create the SQL queries that correspond to the processing, right? Row filter, group by. We have GB row filter. We have GB group by. So try to do as much processing. So that's, you see these yellow nodes. Try to do as much processing inside the database as possible. And then when you're very satisfied with the SQL query you have, right, with the processing pipeline that you have, then you finally do the reader and you get the data inside KNIME. Why is that? Because the databases are usually very optimized and they perform these operations way faster than if you do them in KNIME, right? Also, you don't want all this data in KNIME. KNIME is not a database, so it's not optimized to manipulate data for these operations that are very like SQL oriented. It's not going to be as good as an actual database system. So do that in the database system. And also in your workflows, please use the DB connection closer. We didn't talk about this node, but basically it closes the connection. So, it closes the communication with, say, SQLite and MySQL, and use that once you're done. So playing with the system, right? So once you get the data inside KNIME, you can, add this node here and close the connection. So this is it. Let me stop sharing now. Does anyone have any question before I go to the demo? Okay, so let me share the.
I had one question. When you close, I couldn't see the ports for the close connection.
Okay.
Just take a look at.
Sure. Let me share again.
Thank you.
It's a magenta port. Oh, sorry. Let me share again. Okay, it's a magenta port. You see, so basically, let's suppose that before this DB selector node here, we had a DB connection, right? So you do ta, 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 and then after that, you get the connection and you add here.
So closer just connects to the connection, to the connector.
Yes, because it's magenta, right? It's not maroon. It's not a processing thing.
Okay.
All right. So I see a question here. Could you explain again what it means to the left connector versus the right connector when you were Canon? I would love to, but frankly, I think this might confuse you folks more now. And I'll tell you why. Because you haven't seen.
I think Canon knows a little bit more.
Okay.
So you could explain.
All right. So basically, when you're joining two tables, think again of this one, right? I have the landline information and I have the team I root for information. These are two totally separate tables kept by two different services. And the only thing that they have in common is the SSN. And now for some reason that I don't know what it is, I want a single table with the team I root for and whether or not I have a landline in my apartment, right? So you can consider that the table that has the team information is the left table, and the one that has the landline information is the right table. And you can also consider that I am not the only record there, okay? There are lots of people in these two tables. And in many cases, there will be information both for the team they root for in the left table and for whether or not they have a landline in the right table. But some people, some SSN, some people, you may only have the team information for, so they're only in the left table. And for some people, you only have the landline information, so the SSNs are only in the right table. So when you do this combination, think of two sets, think of of set theory, right? Each one of these tables can be seen as a set. And it is really a set, right? Because the key being unique makes it such that each row is really a unique element. So these are really two sets, right? So this is the left set, this is the right set, and there is an overlap, which is here in the middle. You see, when I do my hands like that, so the intersection of these two sets. And some things may only be present in the left table, left set, and some things may be present only in the right table, right set. And then you have the choice of deciding if you want to keep this information that didn't match in the final table. If you do a left outer join, you are going to have the information for everybody who's only in the left table as well. And then since they don't have a landline, they're not present in the landline table, you're going to have that as missing information. And if you want to do a right outer join, it's going to be the other way around now, right? You're going to end up with everybody who's in the landline table. And then for those that are also present in the team table, you will have the team they root for. But if they're not in the team table, you're going to have missing data. So translating to KNIME, I hope you understood that. But translating to KNIME, since the translating to KNIME, since KNIME works from left to right, there's no such thing as inverting the node and having one input corresponding to the left and one to the right, the left being in the left and the right being in the right, right? As we learned already, everything that is in the right in KNIME is the output of a node, and everything that is in the left is the input of the node. So we had to create some kind of convention, right, to map whatever is the left table to the way KNIME works and whatever is the right table to the way KNIME works. So since both inputs are going to be in the left side, because this is not how KNIME works, right? All the inputs are in the left side. How do we map the semantics? The left table is going to be the top part, and the right table is going to be the bottom part. Is that clear now?
Yes. Thank you. Thank you.
Good. So now let me share my second. Why do I have so many tabs? Everybody has so many tabs, right? But here is my demo. Let me just make it look cute. And now I will share. So that's a very simple exercise that I got from one of our courses that are self-paced. I already mentioned to you that we have all these courses that have video format, right? So you can go and watch them. If you don't know what I'm talking about, Professor Hamed, please send me an email and I'll share the links later with them. But this is one of the exercises in the courses. And basically what you have to do is you have to connect to a database using it's in SQLite. So you have to connect to that. And then there will be some information that corresponds to accommodation, Airbnb information. You're going to do some processing. This information is not in a database, right? It's in a CSV file. And you want to do some processing here. This is, temporal processing, but it could be anything, any yellow node. There's just random processing. And then you want to write this information to the database. But since there was no table there with these attributes, you have to create one. That's why we're using the GB writer node. So let me show you. This is the table you have, right? After all this blah, blah, blah here, all this processing, this is the table you have. It is going to have a key, an ID. Then it has the name, which is a little bit of a description. These are Airbnb rooms to be rented, right? Or apartments to be rented. And then you have this information. It corresponds to New York. And then you have an ID also for the host. So you have an ID for the posting, but you also have an ID for the host because the host may have many Airbnb places that they rent. You have the host name. Obviously, this is not a key. 1 billion people are named John, right? You have that's neighborhood, not a neighborhood, a borough. Brooklyn is not a neighborhood. But anyways, Brooklyn, Manhattan, none of these are going to be keys either, right? You can have many Airbnb apartments in Brooklyn, in Manhattan, so they're not going to be keys. Then you have the neighborhood, and then you have a little bit more of information about latitude, longitude, the type of room, the price, blah, 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 blah. So you have a bunch of columns. In fact, you have 16 columns. You can see the statistics for those columns here, right? We already learned that. So, for all of the different columns, you have the statistics. But what matters is that you want to get this thing here and turn this into a database table. And you want to write that in this SQLite here. So how is this node configured? Let me show it to you. That's the path. It's a local path. It's something that I created for our demo today. Basically, that's the name of the driver, SQLite, and that's the path for the schema, right? The accommodation.SQLite. The schema is going to have the information for all of the tables, what columns they have, column types, and then it is materialized in a SQLite instance that I have in my computer. Then I write. So how does it work? I get the connection and I get the data. And how is this configured? Can you guys see the configuration or not? I don't know if I share it in a way that you can see that. Maybe if I share, let me just share the whole desktop. Now you probably can see better, right? You can see the configuration dialog.
Yes.
Much better, right? Yeah, before it wasn't showing. So it is going to ask you to select a table or to create a new table. In this case, we are creating a new table. That's the name, ABNYC 2019. And we want this table to have all of the 16 columns, okay? Plus, all of the 16 columns that are in the data should be there. And then I write, and I have the option to see this data that was written here inside KNIME. But I also have the SQL query that corresponds to writing this information to KNIME. So let me show this to you, the outputs. The second output is a query, and you're not going to see the query explicitly, but the data is not here. You can fetch a little bit, like 100 rows, just to make sure that it is really in the format you want, but it's not, it's still in database processing. And then inside the database, say that you want to group this information, this Airbnb information, such that you're going to have the prices per neighborhood group. I think neighborhood group is what they're calling borough, right? So you're going to have Manhattan, Brooklyn, blah, 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 blah. And these different boroughs have a bunch of Airbnb postings, and you just want to have the menu aggregation. You want the average price. So this facilitates comparisons, right? So if you come to New York, should you be in Brooklyn? Should you be in the Bronx? Should you be in Manhattan? You want to have an idea of the prices, right, on average. So that's how you aggregate it. And then you are going to have a SQL query that corresponds to that. And if you want to know if you're aggregating it right, if you want to know if you did the processing right, you can fetch a sample from the database and see. This is not the data in KNIME. This is just a sample that we're fetching. And here it is, right? These are the boroughs, and this is the price per night on average per borough. Obviously, Manhattan is the most expensive. And yeah, then you have others, the Bronx, less expensive and all of that.
Now, is there a way to see the query that it creates with the actual SQL query?
Yes. Let me see. In this new interface, I'll get this. I'll ask around, and I'll send information to you. But it was easy to do that, but now maybe not so much. But give me 1 minute. Yeah, but it is possible, or it was at least. I'll check out on that.
Thank you.
I think it's good, right? It's very didactic because then you learn the queries better too. But then I want to join this table, right? That is grouped by the 5 boroughs with the original table I had, that big one with the 16 columns. And they do have one column in common, right? Which is they're calling neighborhood group, right? So this is going to be the column that I'm going to use to join the information. So the group by table, the tiny one, is going to be the left table, and the original table, the large one, is going to be the right table. And when I configure my join, I want to make an inner join. And this is not going to be a key, right? Because there are lots of instances for Brooklyn, lots of instances for Manhattan. It's going to be a key for the group by table because it only has 5 rows, each one corresponding to a different borough. But for the right table, which is the original one, that information is not a key, right? But this is not a problem. What is going to happen is that the information in the left table, which is the average price, is just going to be repeated in the final join table. Let me show the result to you. Let me just get a sample of the data here. So you have everything you had before for the original data, but now you also have this 17th column, which is the average price. And you're going to see that it is going to be repeated a lot, right? Because in the original table, we have many instances for each one of the boroughs. And then again, if you want to keep only those postings that have been reviewed, you can do some filtering inside the database. You can come here and say that that's the equation, right? That's the condition that you want to use. You want the number of reviews. Number of reviews is an attribute. Here it is, it's an integer. And you want it to be more than 0. And then this is also going to create a SQL query. And when you fetch it, you are going to have this filtered information. Then you're finally ready to read this data into KNIME. And now you have for a different table, right? You have the average prices, and you also only have those that have reviews. So you can do a bunch of things with this. You can visualize based on the price. You can create some kind of model, and so on and so forth. So this is what I had to share today. I will owe you this one, how to get the SQL query, but I am almost sure that we have a way of doing that. I'll ask and get back to you via email, and then you can tell the students. But yes, I think that this is what I had for today. Do you folks have any extra questions?
Any questions regarding this whole process?
Yeah, some things might not be super clear because you haven't seen the algebra yet, but that as you play with it, it's very intuitive. It's like processing data in KNIME, but you're doing everything inside the database. Because KNIME is also relational, right? So that's why it's the same thing almost.
So I guess I'm gonna share this video with them. Maybe after we do a few rounds of SQL, they're gonna come back and visit this video one more time.
Great.
Then things will make probably more sense.
Yeah, and I'm writing here on the chat my email. I know that you can always check the slides, but if you have any questions, if you don't want to ask because you're shy, or you need some time to digest this, shoot me a note. I'll be happy to help. Okay? I just share my email here.
Appreciate it.
Great. Thank you for the opportunity then, and I'll talk to you folks soon. That was really cool. I'll send you the slides, Hamed, and an answer to your question, okay?
Thank you. Thank you.
Bye.
Thanks. Bye. I appreciate it.